The product rule tells us how to count sequences when each choice is independent. But often, when you have a sequence of choices, later choices depend on previous ones. That's when we need the generalized product rule. Let's see an example. Imagine a school play where we need to assign 3 different roles: lead actor, supporting actor, and narrator. There are n students auditioning, and no student can take more than one role. How many different casts are possible? Think of each cast as a sequence: first role, second role, and third role. The first role is the lead actor. It's the first one you're going to choose. As we said, we have n students. So imagine we have a set with n students, and we're going to choose one of these n students for the first role, for the lead actor role. How many choices are there? We haven't chosen anyone yet, right? So we have n choices. Any one student of the n students can be the lead actor. Now suppose we already chose this person, and now we need to choose the second role, the supporting role. How many choices do we have now? Now, since one student has already been chosen, we have n-1 choices. n-1 students are left for the supporting role. So we choose one of them, and then the same reasoning applies for the narrator. We now have n-2 choices. And finally, this person also gets chosen. And now we multiply these numbers. The total number of casts that are possible is n times n-1 times n-2. Let's see another problem, this one a little bit harder. Suppose we want to form a 4-digit security code. So 4-digit code. But it has 2 restrictions. First one is no digit can be repeated. And the second one, the first digit cannot be 0. The question is, how many codes are possible? So let's put our digits here. We need 4 of them. And let's choose the first one. It can be any of 1 through 9, because this one cannot be 0. So that's 9 options. Now let's choose the second one. Now 0 is allowed, but it cannot repeat the first digit. So again, we have 9 options. Because we've already chosen one here, but now 0 is available. Now let's choose the third digit, and this time we've already used 2 digits. So now we have 8 options that remain, which leaves 7 options for the 4th digit. So by the generalized product rule, the total is 9 times 9 times 8 times 7, which is equal to 4,536 possible codes. Notice how each choice depends on the earlier ones, right? We always have to look at what has already been chosen to know the number of available choices that we have for each digit.